Exercise 2.3a, question 8. Using the graph of y equals x times x plus 1 divided by 2x minus 1 times x minus 2, shown below, sketch y squared equals x times x plus 1 divided by 2x minus 1 times x minus 2. Okay, no problem. Now, immediately we can see that we have a 0 point at x equals -1 and also when x equals 0. So we know that our y squared graph is going to go through those 2 points as well. We also know that our y squared graph is going to go through the point where x equals, where y equals 1. And the same with, it looks like this point over here. You could find the point exactly simply by setting this thing equal to 1, but for just a sketch, I don't think it's necessary. Okay, now the places where the graph of y equals f of x goes below the x-axis, we don't need to consider those because they're not going to be part of our y squared graph. And well, we've seen this kind of situation before where it's approaching a vertical asymptote. We know that for the y values of the red function between 0 and 1, we know that the y values on our y squared graph are going to be bigger. And we also know that since the tangent line at the 0 value here is clearly has a non-zero gradient, that means that we're going to have to round around so that the tangent line on our y squared curve is parallel to the y-axis. In fact, the tangent line in this case should be the y-axis at that point there. And we know that, yeah, between 0 and 1, all of the y squared values are bigger than all of the y values on the y squared graph are bigger than all of the y values on the y graph because they're between 0 and 1. But then as the y values on this graph go above 1, the y values on the y squared graph are going to be smaller than those, so that means we curve around at this point, and then we should be between that curve and the asymptote. That was horrible. Let me try that again. So I think this is probably the best I'm going to do, but hopefully you can do a bit better. And then it curves around and then goes towards 0 in such a way that the tangent is going to be the y-axis there. And a similar kind of situation over here. All of these y values are between 0 and 1, so that means the y values on the y squared graph are going to be bigger. And again, there's clearly a non-zero tangent line here, so that means we curve around in such a way that the tangent line is parallel to the y-axis on our y squared curve in blue. We have one more little piece to pay attention to, and that is this situation here. So we can see that our graph goes below the graph of y equals, well, the y graph goes below y equals 1 at this point here, which means between this point and, well, forever, I guess. Since it has a horizontal asymptote of y equals a half, we can see just from the composition of that fraction there. So we can see that the y values on our y squared graph are going to be bigger than the y values on the y graph. And so it's going to be like that. It should be between y equals 1 and the y values on this graph here. However, for the y values on this graph that are bigger than 1, the y values on our y squared graph are going to be below. But they're still going to tend to the same vertical asymptote. So that's what it should look like there, although, as usual, hopefully not as wobbly. And then, yeah, that's all we need to consider for this graph. The rest of it is just reflecting it. And so we can do that fairly quickly. Again, it's just a sketch. don't hate on me too much for the wonkiness. Okay, and then lastly, can I go through -1 at this point? And then I guess I'll plot another point over here. And then yeah, that'll do. Okay, so that blue curve is the y-squared one. And we're done with that question.